remind you all of something that we talked about yesterday. I thought we talked about it enough, but I think it's important enough for us to talk about it one more time before we proceed with example 1 and finish it. And it is right here, number 2. Write a primary equation for the quantity that is to be optimized. So this can get a little confusing at times. And so let me just give you just some examples, some thoughts here. Like in example 1, we are trying to, remember from yesterday, we are trying to find when the line is shortest. So we're trying to minimize the line. And so it might be handy to write an equation for the length of the line, or at least some kind of an expression for the length of the line. If I'm trying to minimize the length of the line, and I've got that equation, what am I going to have to do to that equation for the length of the line? If I'm trying to minimize something, I need to do what? Yes. What are some of the steps in between, though?
Take the derivative.
Find its derivative, right? But why would I find the derivative of the thing I'm trying to minimize? What would I do next?
Set it to 0.
Set it equals 0. That would allow me to find critical numbers, and then I could use the first derivative test or the second derivative test. So sometimes this is going to be obvious, number 2 right here. Sometimes it'll be a little bit less than obvious. So let's go ahead and look at number 1 again and see how this goes. I'm going to go ahead and box the stuff and underline the stuff we did yesterday. So it says, when is the line shortest? So when is the line shortest? We are talking about minimizing the length of the line. So I'm going to take a slightly different approach that we did yesterday. It's not that much different. It is just slightly different. I'm going to go ahead and write an expression for length of the line. Okay? You look through the equation, or through the description here. We have a rate, like you guys underlined. We have a rate of J of t and another rate of 7 people per minute. We got all those things underlined. I'm going to make up my own equation, my own expression for the length of the line, because nowhere are we given that, are we? So I'm going to say L of t stands for length of line. You don't have to do it this way. I think this is potentially a good way to do it. So L of t stands for the length of the line. So if I really am trying to minimize the length of the line, what would be the first thing I'd want to find in that process? If I'm trying to minimize L of t, I want to find... Say again? Well, so... That's going to be a problem because I don't have an expression for L of t, right?
Yeah.
And so if we had that, then yeah, we'd have a clear set of steps, right? But we don't have it, and honestly, we don't need it.
So we don't need the J of t minus 7.
No, I didn't say that. I said we don't need an expression for L of t.
Oh, we need it for L.
We need L prime. Does that make sense? I'm trying to minimize L of t, and so I want L prime. So what Mandy was kind of getting at is we really don't have an equation for L of t, so we can't go through and differentiate in the classic sense, right? We don't have anything we do the power rule with or whatever. So what I'm going to do is I'm going to write L prime of t. And the honest truth is, I really don't know what L prime of t is immediately. But if I do go back and look carefully at my what I underlined, I realize that I do have a rate of change at which people are joining the line. That's J of t. And I do have a rate of change at which people leave the line. That's 7. And so here's where we would arrive, basically where we finished yesterday. I would say that L prime is equal to J of t minus 7. Let that sink in for a second. See if that makes sense. What would be a good test to see if this really does make sense? Yeah, we could graph it and we could get some numbers from that, and I think we will do that eventually. But how could I be assured that what I wrote is really true and makes sense, as opposed to, because it would be easy to write some stuff up there that wasn't true and didn't make sense. What would be a key thing to consider?
If they're rates or not.
And how would you know that?
This one, it says the rate at which blah, blah, blah.
Mm-hmm.
Before each of them.
What else besides the rate
There's
word?
People per minute after.
What do we call that?
Uh,
Units. Somebody said units, right? So the easiest way to tell whether you've messed this up or you've gotten this right is to look at your units. So let's look at them. What are the units for JFT? People per minute, yep. And what are the units for the 7? People per minute. And then finally, L prime. So if L of t is the length of the line, what would be the units for L of t? Just people, right? Number of people. So then L prime would be people per minute, right? And so we can see that we have people per minute equals people per minute minus people per minute. If any of those units didn't agree, we've messed it up. And so the bigger answer to the question is, look at the units. If the units agree completely all the way across the board, you've written a good statement that's true and perhaps helpful. If the units don't agree, you got a little problem, you need to go back and fix it. That make sense? Units, units, units. Make sure they all make sense. So I'm going to erase these units right here since we know that they work, and we're going to proceed. So this is basically where we finished yesterday. If I am trying to find where L is minimized, I want to find L prime, and just to review, what do I do with L prime? Set it equal to 0. So I'm going to go equals 0. This is where we finished yesterday. I asked you, how would you solve this? And you all said, graph it and do the calculator. So if you haven't already done that, thought about that, go ahead and grab your calculators. Let's figure out the solution to this equation. J of t minus 7 equals 0 to this equation.
I didn't get it.
You didn't get it, why not?
I
Yep.
don't know what to do.
Okay. Cool.
115.
Maddie's calculator is telling us t equals 32.115. 32.115. What would be the units on that? It's minutes, yeah, because it's just a time value. So t equals 32.115 minutes. Let me just ask you, what is that? Like in the context of our question, we're trying to find a minimum. What would you call that? What have we found, Titus?
That's when the line's the shortest.
Maybe. We haven't discovered or confirmed that yet. We have found a
Relative extreme, that's
critical number, maybe a relative extrema. Because remember, critical numbers are not always relative extrema, right? A critical number could have basically be a point of inflection if f prime, or in this case, L prime, does not change sign. So all we found is a critical number. This is our lone candidate for when the line would be shortest. Now you've seen your graph, haven't you? You hate your graph? Oh man, I thought the graph looked okay. So when you look at the graph, doesn't the graph look something like this? This is the graph of L prime. Let's see here. Did it start right about here and go, or did it cross over the y-axis at all? It did cross over y, so it looks something. That's not really important for us because, you know, t had to be positive, or non-negative at least, right? Okay, so if this is a graph of L prime, then we can conclude right here, what is the behavior of L prime right at our critical number? What is L prime doing?
Going from negative to positive.
Going from negative to positive, which means that L of t is a minimum. It's minimized, yeah. So here's how we would close this off. We would say L prime goes or changes from negative to positive at t equals 32.115. Therefore, L of t is minimized. There, or at t equals 32.115. Okay. So what do you think? Any questions? I have a question for you. This is, your question? Yeah.
I'm just kind of confused how we got to L prime of t. Like, I get why, I get why we don't differentiate J of t and 7.
Okay.
I'm just kind of confused how we know that that's L prime.
That L prime is j of t minus 7.
Yeah, like why is
Like,
it not
how do we
L
come
of
up with
t?
that equation?
Yeah, well, I don't know how we came up with the equation, but like, how do we know that's L prime and not L? Like, why is that L?
It really totally depends on the definition of L of t. Like, if you define L of t to be the length of the line, then the derivative of L of t would be the rate of change of the length of the line, right?
Mm-hmm.
And so you say, I'll just write this up here. So if L of t is the length of the line, like I wrote right here, then L prime of t, that would be the rate of change of the length of the line.
Okay.
Oops, let's not do that. There we go. I'll just put rate of change of L of t. Yeah. There we go. Rate of change of L of t. And so then this is where you'd make the connection back to the wording. You think, okay, so if L prime is the rate of change of L of t, do I have anything that tells me about that? Well, if you underline your rates, you're like rate at which people join the line. So that's the rate making the line longer. And then the rate at which people leave the line. So that's making the line shorter. You got two rates working against each other. The combination of the two will give you the rate of change of the length of the line.
Okay.
Does that make sense?
Yeah.
Okay. So she said something in there that I do want to revisit real quick. She said, I know why we didn't differentiate J of t and 7. Do you all understand that too? They're already rates of change of the length of the line, right? So if they weren't rates of change of the length of the line, then maybe we would have to differentiate. And that's tricky, right? Because you're in a calculus class, right? You think you should be finding derivatives, and so, oh my goodness, we didn't actually differentiate. Sometimes that's going to be the case, like in this situation right here. Okay, any other follow-up questions at all? It's all going okay? Okay, awesome. Let's go ahead and look at the next one. If you guys would take a minute and read it. It is, I believe, about a water tank or sewage tank or something like that. So take a minute for us again. I'll read it out loud. The amount of water in a storage tank in gallons is modeled by a continuous function on the time interval 0 to 7. T is measured in hours. I want you to get something here. There's something huge that's missing. I'll read that first sentence again. The amount of water in a storage tank. Did you catch that first word? Did you catch that first word, amount? Or second word, I guess. The amount of water in a storage tank is modeled by a continuous function on the time interval 0 to 7. T is measured in hours. I got a question for you. Where is that continuous function? What is it?
Is it F minus FT?
Be careful, right? Be careful with this because notice what this says. This says amount in gallons. Compare that with the information given to you about F and G.
Oh, it's not a rate.
Yeah, amount is not a rate, is it? Amount is clearly just simply an amount of gallons, number of gallons, whereas F of t and G of t, those are both rates, aren't they? Maybe you even underline them, right? You know, F of t is a rate, that's gallons per hour. G of t is another rate measured in gallons per hour. So where is this? I mean, look at it. It literally says the amount of water is modeled by a continuous function. Aren't you used to getting the function? Do you see it anywhere?
No.
It's nowhere, is it? They have not explicitly told us the amount function. This is really similar to the one we just did in that previous one where we given a function for the length of the line. We really weren't. So I'm given supposedly there's this function, it's describing the amount of water in a tank, and it's continuous, and it's all neat and everything measured in gallons, but they don't tell us anything about it. So here's what I suggest we do. I'm going to go ahead and say there is one, like they said, and I'm going to name it. I'm going to say that A of t, this is the amount of water in the tank, and it's measured in gallons. So I'm just going to go, you don't have to do it this way. I would hope that eventually you'd maybe see that, and if you chose not to do it this way, you can kind of avoid all this altogether, but I think this is a great place to start. So, we read through this a little bit further. Did you guys identify what this question is asking us to find? Say again, Macy? Yeah. So it says, at what time t is the amount of water the greatest? On the open interval there, so we're not including any endpoints, just an open interval. So when you see that wording right there, when is the amount of water the greatest? How do you interpret that? Like she said, it's a maximum. Yeah, so maximum amount of water. I'm going to put it like this. It is a maximum of A of t. When is A of t? Because I've defined A of t to be the amount of water in the tank. So I'm trying to maximize A of t. Does that sit well with you? Does that make sense? Come on, I know it's Friday afternoon. You have a million excuses to not be engaged. Get over them. Be engaged.
No, I was saying yes to understand.
No. Oh. I didn't take it that way. I didn't take it that way. Believe me. Yeah, I didn't take it that way at all. But you do have a million excuses to not be engaged. Madison, I was 0% mad at you. You're okay. You're totally okay. All right. So let me take you through the steps. We've done this a bunch. We'll keep doing this here. If I am trying to find the maximum of A of t, what should be my first step? Be specific. Don't just say the derivative. Say, or a prime. Yeah. So find a prime. So I'm going to say a prime equals, and here's where you run into a little bit of an issue because they did not give us a of t. So you can't just go through and differentiate, do the power rule or whatever. You can't just do that. You're going to have to find a new expression for a prime, right? So let's keep this in mind. If a of t was measured in gallons, a prime of t would be measured in what? Have you seen anything else describing gallons per hour in this question? 2 times, right? Hopefully you underline those rates. F of t is a rate, G of t is a rate, both in gallons per hour. The question is, how do you combine them? You see how F and T and G of t are kind of working against each other? So how are you going to put these down on your paper? Like, how do they work together to give us a prime? F minus G. Okay. So why did you guys choose F to be positive and G to be negative?
F enters the tank and it makes it bigger.
Yeah. F is making the amount of water increase. G is making the amount of water decrease. And so it needs to be F minus G. That makes perfect sense. So far, so good? Do you see how this is the same question as the line, presented totally differently, but it's the same question, isn't it? I've got rate in and a rate out. That's describing the overall rate of change, in this case of the water, before it was a line. Make sense? Questions? Or I call these competing rates or a net rate type question. Okay, let's take it a little bit further. We just found a prime. In order to find the candidates for maximums, what do we do with a prime? Set it equal to 0. Also consider what? Sorry? Also consider what? No. Because notice what it said. It's DNE is what I'm looking for. Notice what it says. On the interval 0 to 7, open on 0, open on 7. There are no endpoints. There are no endpoints to consider here. So just looking for only critical numbers. So, can you tell me? I've got the graph written over there for you. Did you guys recognize which graph is which? So the curvy graph would be which one? F or G? F, yep. F is the curvy graph. G is the piecewise linear. So how many critical numbers, I mean, we probably need to figure them out, but how many critical numbers do you see going on? More than 2. So please don't say 1 or 0. So some number over 2, 4 is too high. So there are 3. You got it bracketed right in there. Nice job. Okay, so let's look at the graph. Let me explain how I know this. Check this out, please. On the graph, anytime I have an intersection point, wouldn't that be a place where f of t equals g of t? And if f of t equals g of t, the difference between them is 0. So an intersection point would represent where f of t minus g of t is 0. Where am I getting that third point? The jump, right? Did you notice it's a double open jump? And so right here, we know that that's t equals 3 based on the piecewise function. That's a double open jump, which means that right there, because g of t doesn't exist, that means that a prime doesn't exist either. Right? Because a prime is made of f of t minus g of t, so if g of t doesn't exist, well then the whole thing doesn't exist. So I've got 3 candidates here. I'm going to actually get rid of my box there so we can see a little more clearly. I've got 3 candidates. Let's see if we can explore these a little bit. Can you guys use your calculators to find out what those intersection points are? We know one of our candidates is 3, so I'm just going to go ahead and write t equals 3. Please use your intersection feature of your calculator or perhaps your zero finder, depending on how you want to do it, to find the intersection points as well. T equals 3 is the first one. So intersection points, are those good? That makes sense? Okay. So this question, we're just about to finish it up here. We're trying to find the maximum of a of t. And so to find a maximum of a of t, like a relative maximum, wouldn't a prime have to go from positive to negative? Right? Using the first derivative test. So we're looking for where a prime goes from positive to negative. So I really think we can look at the graph to help us with this. So let's just look at this in terms of these different intervals. So right here on the interval from 0 to 1.617, what do you guys think? F of t minus g of t, is that going to be positive or negative there on that interval? Look at the graph. The graph will tell you what you need to know. Remember, this is a graph of g of t and f of t.
Can you repeat the question?
Sure. So on that interval that I just drew an arrow to up there, from 0 to 1.617, is f of t minus g of t going to be positive or negative? Negative, because isn't g of t bigger than f of t right there? Okay, so that's negative. So that right here on this interval, a prime is negative. So this is not looking good for our first critical number, is it? We're trying to find a maximum. Not looking good at all, because if we look at this interval right here from 1.617 to 3, isn't f of t bigger than g of t? So therefore, f of t minus g of t would be positive. So right there at that first critical number, a prime goes from negative to positive. So what does that mean about the 1.617? It's a minimum of a, isn't it? It's a relative minimum right there. So that's not the answer to our question. Let's keep going. So I already found a prime's sign on the interval from 1.617 to 3. How about a prime's sign from 3 to that 5.076? Negative, because isn't g of t bigger than f of t there? G of t is literally above it, right? Above f of t. So I'd say right there, a prime is negative. So what does that mean about our critical number of 3? That's a relative max, right? Because a prime goes from positive to negative right there. So that very well could be our answer. If we look at the final interval from 5.076 to 7, wouldn't it be true that f of t is bigger than g of t? Therefore, f of t minus g of t would be positive. So a prime is positive right there. So at 5.076, a prime goes from what to what?
Negative to positive.
Negative to positive, making 5.076 another relative min. I want to give you guys a little perspective and connect this with something we've done before. Can anybody describe what I really just did using things that we've talked about in the past? I just really made a sign chart, didn't I? You see it? I used the graph of f of t and g of t to help me make a little sign chart. That in and of itself is not the end. Like, that's not good enough. I need to write a little sentence. So I think I'd do something like this. A prime changes from positive to negative at t equals 3. Therefore, a of t has a max, relative max, at t equals 3. So I've got my sign chart. That's all really nice and good. It can help me see a pattern, but it's not an actual conclusion or justification until I write the sentence there to get it finished. All right, you hanging in there? Yeah, question?
Do we have to apply it to the question now? So say this is where the water is greatest and get the answer?
So that's a really wonderful question. The way that I've written it, so it didn't ask for what the amount of water was. We actually don't have the capability yet of finding what that actual maximum amount was. Based on the way that I wrote this, because I said A of t is the amount of water, then for me to say that A of t has a max, I really am saying that the amount of water is the greatest, right? So if I don't pre-set that up, then yeah, I probably should. But because I tied that all together already at the start, I could just use A of t freely to mean the amount of water. Yeah, great question. So that really is always going to be true. Like if you're going to make up a function like A of t, you always want to say, this is what it is. I think that helps you to understand how to use it, and it helps me understand what you're trying to communicate. So, great question. Keep going. Anybody else? Okay. Awesome. So we got 2 more to go, and we should be around. Okay, what speed will maximize the flow rate on the road? Definitely, that's the question. That's what we're trying to find. Let's interpret this just a little bit. Obviously, you all see this word right here, maximize. Right? That's pretty obvious red flag. What specifically are we trying to maximize in terms of maybe some of the other stuff we have up there?
It's maximizing the rate of speed.
Ooh. It specifically says what speed will maximize the flow rate.
So F.
F. So that's what I was going for. We want to maximize F. So max of F. That's specifically what we're going for. This is where this gets a little bit strange. So let me just take you through some of the thought process. If we're trying to find the maximum of F, what should be our first thing we're trying to find? Before critical numbers, F prime. Okay? So I'm going to try to find F prime. Now I want to point something out. Did you guys underline any rates? Did you underline like, hey, flow rate is F equals this? So here's what's this is a strange question compared to what we've been doing. I want to compare this with the other two questions. In question number 1 and question number 2, question number 1 was length of line, question number 2 was the water tank, right? In question 1 and question 2, how many times did you actually physically differentiate something? Never. You never did you? I want you to compare this with something, because you might be thinking, oh, I see a rate up there, what's going on? Here's your comparison. In question 1, it said minimize length of line. Minimize length. So we had some rates describing the rate of change of the length of the line, right? Question 2, it said maximize the amount of water in the tank, and we had some rates of change of the amount of water in the tank, right? Here, we're trying to maximize flow rate. So like what you guys said is so perfect. If I'm trying to maximize F, then I have to find F prime. Do I have an equation for F prime? Not yet. What am I going to need to do to get it? For the first time, I'm actually going to have to differentiate. Because I'm not trying to maximize the amount of cars on the road. Right? Think about that. If I was trying to maximize the amount, literally like the sheer number of cars on the road, then maybe this would already be my derivative, wouldn't it?
Yeah.
But I'm not trying to maximize the amount of cars on the road. I'm trying to maximize the flow rate. I'm actually trying to maximize the rate.
So this would be like the second.
You could almost think of it like that, right? You could sort of think of it like that. Yeah. And so F prime is really where we need to go. So we actually are going to have to differentiate. Does that seem logical? If it doesn't, or if you have a question as to why we're differentiating now, let me know. I hope that does make sense. We do have to do a quotient rule here, so a little review for you. It's good. Come on, low D high minus high D low over the square of us below. It's not that hard to do. I'll do it quietly up here, and we can compare notes in a second. I'm going to clean this up a little bit, and we can compare. I would suggest you do the same. When you're ready, check it out. I strongly suggest you simplify it a little bit to get to that second way of writing it. Rolling. So if I'm trying to maximize F, as you guys suggested earlier, I need to find F prime. Here I had to actually find a derivative physically and differentiate something using the quotient rule. So then once we find F prime, what do we need to do with that? Set it equal 0, and also consider DNE, right? So let's at least consider the DNE right here. So what would cause a fraction to not exist? Right, so let's think this through. What number for V, what input for V might cause that denominator to be 0? Well, yeah, if you plug a 0, you just get 22.
Root 22 divided by 0.02.
Well, so root 22 squared would be 22. The 0.02s would cancel out, but you get 22 plus 22.
Never mind.
Negative root 22.
You mean the square root of negative?
No, negative square root.
But then you would just square it and it would become, because it's v squared, right? Whatever you plug in for v,
Times I.
yeah, you know what?
I swear if we throw I's in.
You know what? Titus is right. The only way we can make the denominator, stop, hey, the panic needs to go back down. The only way we can make the denominator 0 is to start considering imaginary numbers, and we don't do that here. We live in the real world here, the real number world at least. So the bottom line is there's no real number that will cause the denominator to be 0, and so we can safely ignore the DNE. But equals 0 for the overall fraction is in play. What part of a fraction makes the whole fraction have a value of 0? Only the numerator. Yeah, so I'm going to just set the numerator equal to 0 here. 22 minus 0.02 v squared equals 0. Remember, all these equals 0 points are actual points on a quiz typically. That tells me that you know what you're doing as far as finding candidates and so on and so forth. So we just need to solve this. Take a minute, use your calculator to maybe finish it off. Maybe 22 divided by 0.02 square rooted. Let's see here. So it'd be about the square root of, it'd be square root of 1100. 33.17? Sounds about right. 170? 166. Let's always stay in habit of doing the 3 decimal thing. So v equals 33.166. All right, so let me just ask you again, what is it that we have found right now? We found a critical number. We haven't proven anything about this. We haven't determined whether this will maximize flow rate or anything like that. We don't know yet. It's not that it doesn't, we just don't know. So I've got a critical number. What do you guys suggest as far as a way to test this critical number out? Do you think we should use a first derivative test or a second derivative test? First would be easiest. Do you know why first would be easier? Well, we already know the first derivative, and to find the second derivative, so another quotient rule, another more complicated potentially quotient rule, less fun than just doing a quick plug-in on f prime. So I would encourage you guys to do a little sign chart for f prime with your critical number in there, and then once you do that, we should be able to draw a conclusion. Mandy, your question?
So we don't do plus or minus 33 because speed's always positive?
Correct. Plus or minus technically is correct, but we'd ignore the negative side because we're talking about speed. So test values for those intervals, you guys using maybe like 32 and 34, I don't know. Make up your mind about which ones you want to use. Ashley, you mind sharing what you used for the left interval test value?
I was using 33.
33, okay, so f prime of 33, and let me know once you got it. Since we're asked to find a maximum, we're really hoping that f prime of 33 is positive, yep.
Yeah, positive.
Specifically which number?
It was a really small decimal, but it's like 0.00014.
1.4? Okay. All right, so you always want to supply numbers when it's possible. Here it's very possible to do that. Clearly that number is positive, and so that's the most important part about that number. Riker, did you do the right interval yet? Did you test that out? What number did you use to test it out?
36.
Okay, so f prime of 36. What'd you come up with?
Negative 2.25 to negative 6.
Negative 2.25 what?
Negative 2.256 to negative 6.
Oh, times 10 to the negative 6th? Oh, okay, gotcha. So again, a really tiny number, right? Okay, I'll trust your numbers. People watching this video in the future might disagree with you and say, no, he was totally wrong. I'm trusting your numbers. So that's obviously negative. That's the most important part about that number. So in the end, we can say that f prime goes from positive to negative. Therefore, f has a relative maximum. Yep. So we'd want to finish it off by actually writing something like that. So I will write my conclusion down here. F prime changes from positive to negative. at, what would it be at? What equals 33.166? V, yeah, at that particular velocity, V equals 33.166. Therefore, F is maximized at that speed. Still hanging in there. Questions, concerns of any kind? Yes, ma'am. Chloe.
So does the F have to be capitalized or lowercase, or does it?
Since there's not a lowercase F to consider, I'm not too stressed about that. And I don't think that I would ever give you something like that where I'm going to have to make a judgment as to whether, did you talk about little f or big F? Yeah, I don't want that headache, because I want to give you points and I don't want to be causing myself extra stress about letter formation. Yeah, great question. So if you're capital F, you can kind of see my capital F kind of morphed a little bit into what could be thought of as a lowercase f possibly. So yeah, I would be just as guilty as anybody else perhaps if that was the case. All right.
Do we have to have do we have to say what f prime is?
You mean for your test values?
Yeah, so so f is the flow rate, so what would f prime be?
Okay.
The rate of change of the flow rate? Like, do we have to have notation for f, and to say what it represents?
To say what f prime stands for?
Yeah.
No, I don't think so, because f was already defined for you, and so to write down f prime, I know that means the rate of change of that thing, whatever it is. So in other words, you didn't make f up, right? Like, this was already defined for you. If for whatever reason, like in examples 1 and 2, you wanted to make up your own function to describe something, you do have to describe what that is.
Okay.
And maybe even include units just so you don't get confused too.
Right.
But here, we didn't have to make anything up, so I think we're okay.
Okay.
Yeah. All right, you guys ready to finish up this section? This is like rich stuff, but it's also challenging, right? Like, God forbid, it might make you think just a little bit. It's not just like turning you into math robots. That's the hope anyways. Okay, so let's take a look at our last one. It's about a farmer. Example 4. I'm going with colors because it's Friday and I feel like colors. There's my river. There's the pasture. Doesn't that look peaceful? Yay.
Oh,
Come on.
it's so cute.
Okay, here's the fence. My fence kind of goes into the river. Let me fix that. I'm going with cows too.
Hey, you want to take 12 minutes to draw some back? Isn't nature beautiful?
Probably didn't think you were going to get a nature lesson today, but here we go. Got a bunch of black and white cows. Maybe a couple of just white cows. I'm just killing time while you guys get things figured out. Here's a brown cow. Am I allowed to have fun in my own classroom? I think I am, so I will. There's all my cows. You get it? Whatever. Obviously, there's no need to draw cows. There's no need to have color, but you probably ought to have a fence and a river, right? It's the main thing. Okay. So, the distraction of my wonderful art notwithstanding, let's see if we can handle this. Let's go ahead and look at what we are trying to find. What is our end goal? What are we trying to do? Yeah, what dimensions? So yeah, length and width, I agree. And I heard somebody say least amount or minimum, right? So least amount does mean minimum. Minimum amount of fencing. No fencing is needed along the river. So we're trying to minimize fencing. So I'm sure to you that makes sense as far as why this farmer would try to minimize the fencing. He didn't want to spend more than he needs to, right? Doesn't fencing cost money? So if he's going to buy more fencing than he needs, he's not being very smart with his money. He's going to try to buy the least amount of fencing to get this area contained. So can I ask you a question about geometry? When I use the word amount or the words amount of fencing, what geometry concept do you think of? Perimeter. So we could really say that we're trying to minimize perimeter of fence. Minimize the perimeter of the fence. So if we are trying to minimize the perimeter of the fencing, we need to have an equation for the amount of fencing, don't we? For the perimeter of the fencing. So to do that, I think we need to look at our picture, and maybe we should label our picture. Tyler, how would you choose to label the fencing and everything there in the picture? Because we don't know any of the links.
Just like, L for belong, in there, and then the two little ones. W?
So for L, you said L and W.
Yeah.
That makes sense to you guys? Could it have just as easily been X and Y? A and B, C and D? I like L and W because it has to do with a rectangle. I think that makes a lot of sense. But you just need to label the sides of the fence, realizing that the parallel sides are equal and then the other side is not necessarily, right? Because it's a rectangle. Okay, so we need to write this equation for perimeter. So I'm going to go ahead and put P equals, how would we express the perimeter of just the fencing in this case? L plus 2W, yes. L plus 2W would exactly be it. We're going to find, though, for the first time we have an issue, and here's where we have an issue with this. Wouldn't your next logical step be to find P prime? We got the equation for perimeter. If we're trying to minimize perimeter, don't we set P prime equal to 0? So the reason why we have an issue is because P is in terms of not one variable, but two. So would it be dPdL or dPdW? Right? You remember implicit differentiation? We'd have a little bit of a problem here. This is a relatively easily fixable problem because there's one thing in our description that we have, up to this point, somewhat ignored. There's another requirement for this pasture. What is that talking about? Area. So I'm going to go ahead and write an area equation too. I know that my area has to be 245,000, not more or less than that, but apparently exactly that. According to the picture that Tyler set up for us, 245,000 would equal what? L times W. So then how could I use that to help me in my other equation? I could substitute, couldn't I? I think what I will do is I will try to get rid of the L in the other equation. So I'm going to divide both sides by W. So L equals 245,000 over W. So I can then go to the other one and replace the L or substitute in for the L with that. So it would be P equals 245,000 over W plus 2W. Now we have a much happier thing because P is written only in terms of W. I can just straight up differentiate this without being concerned about multiple variables. As far as differentiating, do you see the quotient rule trap waiting for you? What should I do? Move up. Yeah, flip it up. So I'm going to write P equals 245,000 W to the negative 1 plus 2W. And now this is going to be fairly easy to differentiate and find minimums or maximums, whatever we're trying to find. So I'll let you guys finish this one off, and we'll compare our answers here in a couple of minutes, and we'll be done. I think my cows look very happy, don't you? It's a nice pasture. We gotta do this so that we can finish on time. So we have our equation for perimeter. That's all well and good. Now we need to find P prime and consider where that equals 0 or doesn't exist. So P prime is equal to negative 245,000 W to the minus 2 plus 2. Can anybody tell me what is the only value for W that would cause P prime to not exist? 0, right? Because isn't W to the minus 2 a denominator? Let's think about how that doesn't really make sense for our realistic domain. For him to have a width of 0, he's not going to have a pasture. It would just be a straight line of fencing, right? And so you're not going to really be able to contain any cows in there. So because this is a farmer in a pasture, I think W equals 0 is not a realistic candidate, right? So we ignore that and we say equals 0 should give us our only possibilities here. I don't know what you guys did, but I would say at this point, realizing that W to the minus 2 is really a denominator, I would clear that fraction by multiplying everything through by W squared. You're all looking at me like that's, okay, yeah, does that make sense? So I would multiply through by W squared. That would give me negative 245,000 plus 2W squared equals 0. So the W squared would cancel out on the first and the last term, but not the middle term. And then I would just solve. So I'd get W squared equals 245,000 divided by 2. Square rooting both sides. Is W really equal to 350?
Yeah.
Am I remembering that right?
Yes.
Okay. So W equals 350. So what we'd want to do is either a first or second derivative test. Please don't pack up. I still got plenty of time here. I honestly think a second derivative test is faster here. Check this out. The second derivative would be P double prime equals positive 490,000 W to the minus 3. So if I just plug 350 in there for W, can you see how this will guaranteed be positive? 350 to the negative 3 is positive, and times another positive will be a positive. So I can say P double prime of 350 is positive, therefore P is concave what? Therefore, W equals 350 does what to P? Minimizes it or maximizes it? It minimizes it. Minimizes P. It did ask for both dimensions, and so I think we'd want to say in the end it's 350 feet by, was it 700? If you plug back in, I think you get 700 feet. So since it asked for that, you've got to put that. But the important stuff there is the calculus with the first or the second derivative test. Was that successful for you guys? That worked out okay? Awesome. Don't forget that next week is your loop quiz.